All right, so welcome everybody to today's talk being done by Ken Goodwin and myself. I'm Richard Beaver, the CISO at Duke University, and we're going to be talking to you today about two of the services that are part of the Research SOC initiative. And our talk is titled Both Sides of the Looking Glass, How Vulnerability Scanning and Honeypots Can Work Together. So Ken, quick introduction.
Hi, everybody. I'm Ken Goodwin. I'm the Director of Networking at Pittsburgh Supercomputing Center. So a question that is often asked is, who is the Research SOC? And it is a project that is headed by Indiana University that provides operational security for science projects and researchers. It includes a project liaison that is assigned to a science project or a team of researchers that actually provides some personalized interactions. Virtual security teams is an option that can be deployed when needed. As part of the Indiana University effort, it integrates the OmniSOC, which actually starts providing eyeballs on glass. So watching real-time threat data and analysis as things happen. But in addition to that, and this is where everybody else comes into existence here, you have UC San Diego, which is providing training for higher ed InfoSec people. This is really to try to bridge the cultural gap that exists between researchers whose primary interest is their research project, and information security specialists who are tasked with trying to keep things secure. So it's sort of trying to create a common language between the two, if you will, and have each other understand the other's position and efforts. The Pittsburgh Supercomputing Center offers vulnerability scanning services, which we will talk about here in a few moments. And then at Duke, we have Stinger, which is the shared threat intelligence, which Richard will talk about here in a few minutes. So as I was mentioning, what we're covering today is what is the Viz service and what is the Stinger service, and actually using them together to create something very powerful. So Viz is the vulnerability identification service, or as I like to call it, what doors did I leave unlocked? It's based on the vulnerability scanning service that's offered by PSC's regional network, 3 Rocks, to its members. It uses the Greenbone Vulnerability Manager. It produces an inventory of active hosts, services, and problems as seen by the outside world. Next slide. Viz in action, it probes for active IPs. It creates an inventory of active hosts in an IP range. It then proceeds to scan for vulnerabilities and services. At the end of the scan, it creates a custom report. There's actually 2 versions that are created. One is machine parsable, so it could be uploaded into an analysis stack of some sort, and a human readable version, which is shared with, in particular, in this case, either the project liaison and the Insight, and export it automatically so that we can get rapid data into the system. It's interesting. I'll put it out there that no one ever runs clean. If you think about in today's age with so many pieces of software that's needed to do a project or create a system, it's very hard to lock down the infinite variable space that happens. And because of this, and because we all have finite amount of time, it's very hard to prioritize the issues, and it can often be difficult to mitigate or correct them. Sometimes you are locked into a version due to an API requirement or just time. So, that's sort of setting the stage for what do we need to do next.
So as we shift gears a little bit, when we take a look at something like a Viz service, which, I like how, Ken, you put it, that this is the thing that tells you what doors are unlocked. Stinger is a service which tells you who's banging on the doors you're trying to get in. And we developed Stinger, which is an acronym, a rather tortured acronym that stands for Shared Threat Intelligence and Network Gatekeeping with Automated Response, is a way to deploy our own sensors, in this case honeypots, and collect information about what is targeting our network space, and then turn around and either take action on it, either in a very proactive fashion, quickly adding that to our network defenses, or being able to retrospectively look back to see, was there contact with machines that we should be concerned about. And then the real power of Stinger, we strongly believe, is the sharing of that information between other Stinger partners so that collectively we are protecting our networks. Wouldn't it be great if say, the university down the road saw an attack first, shared that information with us, and we were able to stop an attack before it happened, and vice versa. So that is what we believe to be the power. Inside of Stinger, and we've talked about this at in previous conversations, but honeypots, it's kind of the old adage of what's old is new again. Honeypots are a cheap, easy source of threat intelligence. You put them out on your network, they're designed to be hit. You can have them run any number of different types of services, and you get a very low false positive rate. You expect anything touching your honeypots to be malicious or maybe misconfigured at, best case. What this means then is within the Stinger framework, we have an easy way to deploy sensors onto the network. It gives you immediate feedback and actionable threat intelligence about what is targeting your network. And it also provides kind of low friction between your faculty, researchers, and students and the security teams that are defending the network. To give you an example, SSH, which is a very commonly used port, we'll see a little bit about that later on in the presentation. It's a very commonly used service for remote access and transferring of data. And traditional enterprise grade security systems tend to look at traffic and say, if you see so many connections of this type within this period of time, then assume it's bad and block it. So you can imagine where that could run afoul of some researchers or even students who are trying to move data via processes that require several SSH logins in a short period of time, which could mimic what an attacker does. And in this case, what we have found is that by using something like Stinger and getting dynamically that information about what is actually trying to abuse remote access ports, that has reduced the false positive rate amongst our researchers and students and improved our relationship with them. So the other thing that we have found to be very helpful with Stinger is the type of data that it's collecting. And just to kind of give you a very brief overview of some of the information, we do have good data coming in about things like where attacks are originating from. So, when you look at the map and you look at some of the data here, you see some of the expected players in the list. You also see, from time to time, you'll see countries like Vietnam or I think in one case, Brazil popped up. Other cases, we've had some European countries pop up in terms of week to week or month to month. And what that kind of tells us is it just speaks to where infrastructure is being used to initiate some of these scanning attacks. The other piece of data that we have that we've been collecting that we don't show in this particular slide here are the ASNs. And so by looking at the ASN ranges, we can get a feel for which ASNs or maybe more clean or less clean than other ASNs. And that's been pretty eye-opening. And then when we look specifically at our partners today, we've got roughly 27, 28 partners that are using Stinger. And when we look at that, the key theme that we see is that the more people that are using Stinger, the more new and unique addresses we see pop up. On the right-hand side, you can kind of see where the overlaps are happening. And while that is good to know, we would note that as we've added partners over time, we have seen a decrease or an increase, I should say, in terms of the uniqueness of the the attacking IPs. And what we find is that that's going to be very useful, because the more of these sensors we get out there, the more people that are using it, then the more ably we are to identify new and unique attacks. Oops. So go ahead, Ken.
I was going to say, you know, that's a unique observation in you know, the coverage space of IP addresses.
Absolutely. It's, yeah, I would say from that, we're learning more every day we run it. And what we're seeing is listening and looking at different services. That's really kind of showing the power, as well as the diversity of types of attacks and where the attacks are coming from.
So I think you know, these tools are very powerful in and of their own right and very useful. But I think the interesting aspect of this is combining Viz and Stinger, and some of the power that you get by looking at both those data sets and seeing how that applies to you. You know, individually, each service, as I said, is very powerful. Viz, you know, reduces vulnerable services that could lead to a compromise of some sort, or data exposure or corruption. You know, it helps you identify your problems. You know, while you're presented with a long list, you can prioritize that list and take action to remediate the problem, and then track basically what is the security health of your site as you go along. On scenario one, you know, we want to talk a little bit about combining these services and what you could do. So, you know, let's talk a little bit about SSH. You know, let's assume you have a network and you have some exposed systems and maybe some inadvertently exposed systems. And you have a bad actor that's out there actively doing SSH scans, trying to see, you know, do these credentials work, or is this version vulnerable, or, you know, what have you. So with Viz, you actually have an inventory of all of your systems in your network that are known to have exposed SSH to the world. So these are the systems that are available, if you will, to the bad actor. And it gives you a catalog of what versions they're running. So the interesting part is, by adding Stinger to this mix, you also have the honeypots that are out in your network. And these are also being probed by the bad actor. And Stinger actually notes this and alerts, you know, the OmniSoc as well. And it can be used to actually dynamically update your firewall to start actively blocking the bad actor, as well as letting you know that someone's actually probing for this, you know, this vulnerability, or actively probing your site. So maybe you need to up the priority level, if you will, on updating your SSH versions.
Yeah, and just to add to that, the power of doing something like this, organizations sometimes will have difficult times identifying areas of risk in their network or in their program, and then figuring out, you know, like Ken, how you put it with the vulnerability pieces, but figuring out how to prioritize how to manage those risks. And between these two services kind of working together, you get a very easy and effective way to pull some data in to at least explain or show what that risk level is, right? So from a Viz perspective, you're going to get that read, as Ken pointed out, that, hey, you know what, we're running, you know, X number of systems with SSH, which is very common. It's needed service for our researchers, and those systems are exposed to the internet. So you go, well, that's great. So we just need to keep them patched and up to date. But knowing which ones need to be updated, that's kind of the key there. And then what Stinger does is it shows you, well, that's great. You know, you're keeping them patched and up to date. But by the way, did you realize you're getting X number of scans or attacks against the service on your network on a daily, weekly, monthly basis. So is that something that leads to a discussion about, do we need more security, right? Do we need SSH behind another security layer? Do we need multi-factor? Do we need to do something from a monitoring perspective to protect that service? And keep in mind, we're just talking about SSH, but if there are other services that are running, whether it's web, other remote access protocols like RDP, if you go back a couple of months ago and look at the F5 vulnerabilities that were announced back over the summer, any of these could be cases that in which using Viz and Stinger provides you that really quick tactical reading of, here's the risk I'm dealing with and what should we do about that. The other really cool thing that we've seen and we've experimented with on a certain scale is taking a look at research equipment itself. So when you get into research labs or you get into environments, it's not going to always be a server or a desktop or a laptop or something like that. It's not always going to be that computer system. You're going to have devices. They're going to be lab equipment. It could be an IoT type of device. Think about the whole medical IoT device landscape, things like that. So Viz takes advantage of a number of technologies here, or another number of approaches that could be used to fingerprint a device. So simply by pointing Viz at the thing and scanning it, you can get some interesting information out of it. What ports are open? What banners or what services are running on those ports. And that information can be turned around and used within Stinger then to build honeypots, build custom honeypots that are made to mimic or look like these devices. And then once that's done, you can deploy those honeypots out on your network and start getting intelligence back in. So what this does is it does kind of two things, right? One is it puts honeypots out there that looks like other devices. So you're kind of, in a way, masking. It's the idea of deception technology. But it's putting more of them out there so the attackers are seeing lots of them as opposed to, one or two potentially. The second thing it does, though, is it starts giving you information about what is hitting those types of devices. And again, that goes back into that risk calculation. Do we need to do something about it? Should these be behind another layer of protection? How do we monitor and identify those devices that are being hit, as well as getting intelligence on if an attacker connects and is able to spend time on that honeypot, what they could potentially do on it, right? What URLs are they calling out? What type of software, malware, et cetera, are they trying to drop on it? What commands are they running? Things like that. So it becomes a very useful tool from an intelligence perspective and helps inform that risk. Okay, so that is all we have for today. We do thank you for joining us and listening in on this. We will be doing a question and answer session next week during the Cybersecurity Summit, and we welcome anybody joining and asking us questions or talking some more about what we have going on with the research SOC.
Yes, and again, thank you.
Yeah. All right, take care, stay safe, everybody.